So this is a electric circuit simulator which is designed by Science First company, and it shows it's a really good arrangement to show how electric circuit works. Because in electric circuit, what is current? What is current? Remember definition of current? Flow of electrons. But the problem is you can't see the flow of electrons. So this simulator helps us to see the flow of water and simulate it with the flow of electrons. So the first thing we do, if you so it's made up of pump here, water pump. So the pipelines here, and that's it really. So what is pump demonstrating here, which is similar to the electric circuit? What's pump doing?
Battery.
Battery, very good. So it pushes the, same as battery pushes the electrons, a water pump pushes the particles of water. So current is the flow of charge or flow of electrons in a circuit, isn't it? So in here you can see the flow of water when the battery starts. So to start the battery, I'm using a rheostat to increase the voltage gradually rather than increasing step by step. So now you can hear the sound of the water pump, the impeller inside the water pump rotating, pushing the water to the left, and you have a complete circuit. And you can see before we start, this is a manometer. The manometer shows how much pressure drop do we have, or you can say in electric circuit it's a voltage. Yeah. Now the manometer height in both sides of the manometer is nearly the same, meaning that there is no pressure drop because we don't have any drop or difference between potential in these 2 points. Manometer is connected in these 2 points. So there is no difference between the potential in these 2 points. But as soon as you start the flow, you can see that you have got some increasing pressure in this side and decreasing in this side. It means that pressure here is higher than here. So you have a pressure drop. The pressure drop in terms of water is the same as voltage drop in the electric circuit. So you can consider this part as a resistance. So you have a resistance. This resistance uses the energy and drop the voltage or drop the pressure. And you can measure how much pressure drop is here. I've added a little bit of stain to the water to make it colorful so we can see better. Now, if we want to better see how fast the water moves, I'm going to add a little bit more stain in here to see how fast it can be circulated in the circuit. It's more concentrated here. It's going to gradually more concentrated toward everywhere in the circuit. So what else we can see here? We can refer to the Ohm's law. According to the Ohm's law, how is current related to the voltage? Current and voltage are proportional, isn't it? Directly proportional. The more voltage, the more current. Does it make sense here? So less voltage, less current, and you can see here, and more voltage or more energy I give to the pump, more flow rate, more current. Okay. The next thing is in the Ohm's law is current and resistance are inversely proportional, isn't it? Current and resistance inversely proportional. In Ohm's law, you have got current V over R. So current is inversely proportional to the resistance. So that means if you increase the resistance, the current should be lower. Or if you decrease the current, resistance should be higher. We have got some valves in here. These can work as a valve. If I close it, you can see I decrease the current. So less current makes more resistance, and the more resistance, now you can see that resistor, so I've got more potential difference between here, more pressure drop here, or more energy drops in here. So by closing that, you can resist the flow of the current, and more resistance, more pressure drop. Alright? So this is a simulation which can help to understand what is happening exactly in the circuit. And also you can use these two as two parallel resistors. You can play with this and see when you have two parallel resistors, how they can interact to analyze the current and voltage. Alright, any question? Make sense? Thank you. That's it.